Hi students, problem number 15. A long solenoid is formed by winding 20 turns per centimeter. What current is required to produce a magnetic field of 20 millitesla inside the solenoid? It is the easiest possible problem in the magnetic field. Okay, direct substitution only. What are all the given quantities? First, the total number of turns divided by the total length of the coil. So this is n, small n. So small n, number of turns per unit length. So that is given as 20 per centimeter. So 20 per centimeter. So in 1 centimeter itself is 20 turns, means in 1 meter it is 100 times. So this is equal to 20 into 100 per meter. So this is equal to 2000 per meter. We have to convert this into SI unit. That is the only chance here. Okay, there is no other difficulty. Okay, then what else is given? 20 millitesla. The magnetic field B is equal to 20 millitesla, means 20 into 10 power minus 3 Tesla. Then when it is kept in air, means mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. So what is asked here? What is the current required? The current required is asked here. So what is the formula required here? The magnetic field along the axis of a solenoid is given by what expression? B is equal to mu naught N into I. Is it not? Therefore, I is to be determined. Therefore, what is I is equal to B divided by mu naught N. So, this is B divided by mu naught into N. Therefore, I is equal to B is 20 into 10 power minus 3. So, this is 20 into 10 power minus 3 divided by 4 pi into 10 power minus 7. So this is 4 pi into 10 to the power of minus 7 multiplied by n. Small n is 2000, can be written as 20 into 10 power 2. So this is 20 into 10 power 2. So that this 20 and this 20 can be cancelled. So this is equal to this 10 power minus 3. So this is numerator is 10 power minus 3 into this 10 power 2 is coming up as 10 power minus 2 into this 10 power minus 7 is coming up as 10 power plus 7 whole divided by 4 pi. So this is 4 into 3.14. So this is now equal to 10 power minus 3 into minus 2 is 10 power minus 5 here plus 7. So the remainder is 10 power 2, is it not? So this is equal to 10 power 2 divided by, this is a product of 3.14 into 4 must be equal to 12.56 because these are standard products, is it not? 12.56 and this is now equal to 100 divided by 12.56. So we will use the calculator. So 100 divided by 12.56 and this is now equal to 7.96. Therefore, I is equal to 7.96. 7.96, which is nearly equal to 8 ampere. It is rounded off. It is rounded off to the next nearest digit. So it is nearly equal to 8 ampere. So which is the option? Option A itself is the right answer. Therefore, the current I is equal to 8 ampere. That is, option A is the correct answer. So it's a very, very direct problem. Only here is number of turns per unit centimeter has been converted into per meter. So after this, it is very easy to solve such MCQs. I hope you must have understood them fine.